Hello, everybody. Welcome to session 4, Finding Volumes of Prisms. Today, we're going to be finding volumes of various rectangular prisms. You're going to need your student book, page 239 for that, okay? You're going to need, you're going to have an opportunity to do some workplaces game where you can do the polygon search or the dragon's treasure game. We do have looking for relationships, which we're going to be doing on a teacher's master. And then when we're all done with today, you'll have page 240 in your student book. Let's go ahead and start off with your homework. This one is in your student book. Go ahead and pause the video and check over your answers, please. So make sure that you are using the correct units for each one of your answers. Remember, our work will vary because how one person ends up figuring out how the answers to these might be a little different, but ultimately what we're looking for is the correct answer. If you have any issues with that, you need a check-in, go ahead and email your teachers and they'll connect with you and hopefully get you on the same page. Here are your answers for your camping trip in Home Connections. Pause the video and check over your answer. Okay, so hopefully you notice that some of these have multiple answers where you could use feet or yards for these to kind of write. And then you're going to answer the rest of them this way. Now, again, work will vary. And just make sure that your answers match these answers. Don't skip the challenge. I know a lot of us like to skip the challenge. Don't skip the challenge, please. Go ahead and give it an attempt. The answer is here so that you can check over your answers. Again, if you find that you're way off and that you need some help with that, it's better to reach out to your teacher just so that they can help you figure out where the confusion might be. All right, so before we start out today, I'd like to go over a vocabulary word called rectangular prisms. Now, in a rectangular prism, we're talking about a three-dimensional shape. It's solid, whose has 6 faces. So 6 faces like a cube, like a dice. And all of the faces are rectangles. And remember, in a rectangle, we have 90-degree angles. That's it. They didn't have anything to do with the sides. We don't have 2 long sides and 2 short sides. And I know growing up, that's our idea for what rectangles were. And now to come to learn that all that a rectangle is 4 90-degree angles, that would have been much easier for me to remember when I was younger. So keep that in mind because we're going to be measuring various rectangular prisms. Now, if we were in our classroom, I would give you these blocks, and these blocks you would be able to decide and you'd be able to see and touch and manipulate various volumes. And you can see how some of them are related. Some of them are, the bottom is the same as the top, but how they kind of fit together and how they look, okay? So before we start, how do these rectangular prisms compare? So how does H compared to I compared to F? So is F related to I and H? How does I relate to H? Are any of them, do any of them have similar volumes? Are any of them different? Like are some half or are some twice the amount in volume? What do you think? So before I give you the measurements, that's what I wanted. I want you to just think about these blocks and how they relate. So how does F relate to I? Well, I think if I put F here, I might be able to put another F next to it. So I might say that F would be half the volume of I. And if I look at F, it almost looks as if I could put another F on top here and it would match the H. So the H would be twice the F. Well, if H is twice the F volume and if I is twice the volume of F, then wouldn't it make sense that I and H are the same volume? Then that looks kind of strange. But if I look, in fact, if I cut H in half and put it down next to it, you'd actually see that I and H are very equal. All right, since I don't have the blocks for you to measure, I've already taken the time to go ahead and measure them for you. Okay, so stop the video and figure out each one of the volumes for A through L, because I'm going to ask you to compare some of the volumes with each other. Okay, and now remember, you're taking the base. Which are the base? It's the length here and the width. That's the bottom part of our rectangular prism. So if I look down here, this is the base. It's the length and the width. Okay, and the height obviously is how tall it goes. All right, so if you could write that down and figure that out. Sorry, I'm just clicking through here, just real quick. Okay, so now that we're done, hopefully you paused the video, and if you didn't, pause the video now, fill out all these in your notebooks. In fact, I'm thinking that, yeah, this might actually be a workbook page for us. I'm sorry. Well, we're just going to keep going around. Student book, page 239. Well, let's go ahead and go back. Well, okay. So anyway, sorry about that. We're just going to scratch that. You're going to go ahead and figure this out. This might be page 239 in your student book. It may not be. If anything, make sure this information is put into your notebooks. All right, so now what I want you to do is look at prisms H, I, and J, right? Now this is what H looks like, this is what I looks like, and this is what J look like. Now if I take a look at H with 2 times 2 times 8, and then I would look at I, which is 4 times 2 times 4, and then I would look at J. J is 4 times 1 times 8. Those equal 32 centimeters squared or cubed. That would mean that they all hold the same amount, right? Does that look like? Would you have picked that out? This looks like a cereal box. This looks like a box or a Pringles bin, and this actually looks like a sandwich box. But yeah, no, I wouldn't have thought that. But each one of these boxes hold 32 cubic centimeters, and they are the same size. Even though they look differently, they are the same size. D and K. D and K also surprised me. Look at this. Both of them are 64 centimeters each. So if I look over here, D is a 4 by 4, which is 16, and 16 times 4 is 64. That would be 64 centimeters cubed. But then I look at K, right? And K looks way thinner and a little taller. So, but then if I look at it, it's 4 times 2, which is 8. 8 times 8 is 64. That's the same number. So those would be the same. Hey, look at blocks D and L. What do you notice about those two? Go ahead and pause the video and look back at your notes. Okay, so initially, if I'm looking at this, it looks like if I stack 2 Ds, it might be an L. Would D be half the size of L, or are they the same? Let's go ahead and check. D is, again, 64, right? And L is a 4 by 4 by 8, which, look at that. It's twice one measurement, and it actually is twice the size, right? 4 times 4 is 16. 16 times 8 is 128. So that is my answer here. So yeah, L would actually be twice the size. Interesting. All right. So for today, you have unit online resources for some extra practice and your April number corner resources. Look for that on our document. You could play the workplaces game again. And you have your student book, page 240. Okay. If you need any more help on this, go ahead and get in touch with your teacher. They'll be more than happy to get back in contact with you through email or whatever whatever communication device you guys are using to get back and forth with each other. If you if you seem to understand this and you get it, awesome. Have a great day. Enjoy those additional practice opportunities and enjoy math.